Hello, welcome to our channel for probability and statistics. In this video, we will talk about a notion in hypothesis testing. It is called the power of a test. The power of a test is actually the probability of rejecting H0 given such a specific alternative test is true. So consider example. We will test H0. The null hypothesis is the success rate in a binomial process is 0.25 for each trial, and the alternative hypothesis is H1, that the probability of success rate in a binomial trial is 0.50. So we are interested in assessing the sensitivity of the test. So this is related to the power of the test. So currently, the test is governed by the rule that we will not reject H0 if there are less than 8 positive in a random sample of 20. So we will seek the capability of the test to properly reject H0 when indeed the probability for success rate is 0.5. So we have seen in a calculation that a type 2 error is given by the beta equals 0.25. So the type 2 error is the probability that you will commit when the alternative test is true, but you did not reject H0. So this is called type 2 error. Beta equals 0.25 in this example. Note that this 0.25 has nothing to do with this 0.25. So the power of the test is 1 minus 0.25, which is 0.75. So what this means? This means if the true probability for the success rate for each trial is 0.50 in a binomial process, then if we do many samples of 20, many trials, each sample consists of 20 random trials. So if we do many times of such 20 samples, right, then the test will be described by properly rejecting H0 about 75% of the time. So what this means? If we do many times of the test, sometimes we are wrongly holding H0. We do not reject H0, but actually H0 is false and H1 is true. So sometimes we will make type 2 error. But if we do, for example, 10,000 times, there are around 70,500 times we will reject H0, and another 2,500 times we will not reject H0. So this is given the H1 is true. So given H1 is true, we have about 3 or 4 parts of the time we will reject H0, and another 1/4 of the time we will not reject H0. So this is wrong, right? So about 75% of the time we are correctly reject H0. So this is the power of the test. So power of the test is quite similar as in machine learning. There is a notion called accuracy. So accuracy is what you say. You have to test the significance and what is correct. So this is the accuracy part of the time. And again, if we change our critical value from 8 to 7, so that means if the scores greater than 7 will fall in the critical region, which means we will reject H0 if more than 7 positive in a sample of 20. And we will not reject H0 when 7 less than or equal to 7 from a 20 sample. So we test again, correct again. If the H0 is 0.25 and H1 is 0.5, we find that the probability of a type 2 error beta is 0.13 now. If we see in the previous example is 0.25, so now the beta is lower and the power is increased to 0.87. So this means when the true success rate is 0.50 in a binomial process, if we set the critical rule is 7, so now test is described by properly rejecting H0 about 87% of the time. So the power is increased if we lower this critical value. If we look at this figure, maybe it will be more clear. So first, we'll see if H0 is true, then this density curve represents the distribution of the positive number, right? This is the how many positive from a sample of 20 in x-axis, and this, if the H1 is true, will have the right shape for the density if H1 is true. This is about the mean of 0.5 and this is the mean about 0.25. So this vertical line is the critical line. This is the critical rule. If less than this value, then we'll hold H0. If higher than this value, we will hold H1. So if we look at the blue area, this is called type 1 error. And the yellow area is called type 2 error, beta. So type 1 error, this area comes from H0, which means we wrongly reject. So actually if H0 is true, but we reject because we get the positive at the right side of this decision line. So we reject H0, but actually H0 is true. So this area is the type 1 error, which means the wrongly rejected area. So we rejected, but we have the probability to commit a type 1 error when actually H1 is true. And on the contrary, for the yellow area, which means we get the positive from a 20 sample lower than this limit. So we do not reject. But actually, this shape means the true H1 is true. So we have this shape for the density. So this area is called type 2 error beta. Which means we do not reject, but actually we should, because H1 is true. H1 is true, we should reject, but we did not because we get the sample positive lower than this limit, right? So this is beta, the type 2 error. This is the non-rejecting area because we wrongly non-rejecting. We have to reject, but we did not. And the power of the test is 1 minus beta. Actually, is this white area plus this. From this shape, H1 choose shape 1 minus yellow area. So all the area at the right side of this decision rule in the H1 density curve. So this probability, this part of the probability represents the power of the test, means the accuracy in machine learning, which means we have the probability to truly reject H0 under the assumption, under the truth that H1 is true. So H1 is true and we actually reject H0. So this is the correctness, accuracy. So this is the power of the test. So this is very important. And in the previous two examples, if we change this decision rule from, for example, 8 to the 7 here, So you can see the yellow area will be less than before, and the power of the test will be enlarged with this part of the yellow area, right? So from 0.75 increased to 0.87 in the previous numerical example. So if you're interested in the examples for the trade-off between type 1 and type 2 errors, we have previous videos for explanation of these trade-offs in binomial process example. Thanks for watching.